Hey everyone. In the last video for this week, I want to talk a little bit about basic principles of data visualization. So in the previous videos, I talked about how we can use graphics and data visualization to explore issues, for example, related to measurement or data exploration, but also emphasize that this is ultimately also a tool for communication when you try to kind of communicate your results to your peers or to your audience in general, right? And in order for data visualization to be an effective tool of communication, we need to kind of be aware of some basic principles of human perception in order to kind of make graphics as effective as possible. Okay, and so this is going to be a quick overview of those kind of some basic principles of data visualization, which are based on Kieran Healy's great book on data visualization, which I already linked on Canvas, and that you should definitely take a closer look at this week. At least read the first couple of chapters and make sure to skim the rest and keep it in mind as a background resource as we proceed throughout this semester. Okay, so we already kind of talked at length about why looking at data and why using data visualization. But just to kind of summarize, um, good visualization methods ultimately offer valuable tools that we can use in the process of exploring, understanding, and explaining data to others. And those are kind of the points that we outline in the previous videos as well, right? Ultimately, whenever you think about kind of setting up a visualization or thinking about how to use graphics to kind of communicate your results, you always have to think about the relationship between the structure of your data and the perceptual features of your graphics, right? And so in the remaining slides, I'm going to talk a little bit about these, how these connect, and how these kind of can help you design ultimately effective visualizations, right? The key question that you always have to keep in mind when you design your visualizations is what are the key comparisons that you want to make and that you want to communicate to your audience, right? And then ultimately, based on that, how can your visualization help you communicate your main point as effectively as possible, right? So there are two different things. On the one hand, of course, there's like effective communication as you're reporting results to your peers, but then there's also the value of data visualization as exploration, where you're basically an audience of one and you're trying to get a better understanding of the structure of your data, right? And so why this is important, this is on the right we have a kind of another canonical example of why data visualization is so important. This is the Anscombe quartet, which basically displays four different data sets with four different relationships between an x variable and a y variable. The key point here is that if you look at measures of central tendency, the standard deviation, the correlation, as well as the regression coefficients across these four data sets, they're nearly identical. And we can maybe in the Q&A session look at those, take a closer look at those as well. But if we look at the actual scatter plot, we see that they represent extreme, like completely diverging relationships between x and y, right? So just by looking at the correlation, or just by looking at the regression or mean and variance, we would think that each of those kind of relationships are exactly equivalent. But as we clearly see, once we look at the scatter plot, they are not, right? They represent ultimately quite different relationships, right? So data visualization is important for both, on the one hand, you understanding and exploring the structure of your data and understanding your results, but then ultimately also to communicate the results to your peers, okay? One way of kind of talking about what constitutes good visualizations or effective visualizations is to kind of show examples of poor visualizations. And this is only conducive to the extent that we can actually think a little bit more systematically why these graphics are ultimately what makes bad figures bad, why certain graphics are not effective tools of communication, right, or to communicate certain results, right. And there are three different reasons of why certain visualizations or certain graphics are problematic, why they're bad, right. The first set of problems is focused on aesthetics, right. So this is kind of summarizing issues where the graph is in some way tacky, tasteless, or just not very pleasing to look at. Of course, this is can be problematic, can be annoying to have ugly graphics, but ultimately they don't necessarily, and they might make it harder to convey key points, but they don't involve any deceptions or anything like that, right? It's purely the aesthetic issues, right? Next, we have substantive problems, right? And here, and we're going to look at examples of that as well, where the graph has problems that are due to the data being presented, right? So there are actually substantive issues with the data that is being presented that can cause issues and potentially even like be deceptive in its communication. And then third, we have perceptual problems, right? So here, it's not the underlying data that is problematic, or the way the data that is being presented, but the graph can be confusing or misleading because of how people perceive and process what they're looking at. So here we can think about again, kind of thinking about the comparisons that are being made, and that there can be, for example, comparisons that are done that are conveyed using different graphical features like size or a length of a bar or colors, and depending on what kind of graphical features used to make that comparison, there can be perceptual biases, and we're going to talk about those in detail as well. Okay, so those are kind of the three broad categories of problems that we have with visualizations and with graphics, and we're going to look at specific examples for each of those in turn. Okay. So first, aesthetic problems or bad taste, right? And so one of the examples that is included in the data visualization book is this one in particular, which is a horrible example for a data visualization. And there are a couple of reasons why this is really problematic, right? On the one hand, of course, we have this three-dimensional visualization, which is not necessary at all. And as a general rule, you should avoid any 3D feature unless it is extremely necessary because you have some multi-dimensional comparison. And usually, even if it is multi-dimensional, there are better ways of doing that than creating a three-dimensional plot, right? The reason why this is so difficult is or why this is so bad is it makes it very difficult to even read the actual values, because if you look at the underlying scale, it's not quite clear what the values actually mean. Is this 46 or is this 50 or who knows? It's unclear. So that's the biggest problem. But there are other issues. One is unnecessary use of color schemes, even though we have a labeling on the y-axis here, and we have redundancies, right? In addition, we have a legend up here that is kind of redundant with the scale on the y-axis. And so all in all, this is a horrible plot, and it doesn't really communicate effectively the underlying content that is that they're trying to communicate, which is life expectancy in across continents. Okay, you maybe have a vague idea of which values are higher and lower, of course, but anything beyond that you can basically not decipher based on this specific graphic. Okay, so that's one example of bad taste. There are other examples like this one, especially in newspapers. You see kind of illustrations that include statistical information. Like this one, we see the total House and Senate campaign expenditures in millions with a nice little monstrous visualization, which of course makes it harder to actually compare these statistics, these values over time. But there's an argument to be made that there have been some studies that suggest that some illustration can actually be useful because it makes certain information more memorable, right? So I certainly wouldn't advise you to create a visualization like that. But depending on what audience you're speaking to, some way of adding some illustration can actually be helpful in order to make it more, at least more memorable, I guess, in some ways. But regardless of that kind of little regardless of that argument, in general, whatever makes it harder to kind of evaluate these comparisons and communicate like the underlying content effectively should be avoided, right? And this is certainly one example for that. Okay, so but the underlying point here is that this is just all about aesthetics, right? The underlying data is not the problem. It's not about kind of perceptive biases. This is just bad aesthetics. Okay, so let's look at the substantive issues. So when we actually have bad data, and this is a really interesting example. There's an article that was published in the New York Times that discussed the percentage of people who say it is essential to live in a democracy across several developed countries. And they kind of show a shocking decline in kind of how important people view democracy, both in the United States as well as in other countries, the Netherlands, Australia, and so on, right? And this is based on World Value Survey data. So this kind of produces kind of a shocking or conveys kind of a problematic trend that suggests that people don't care about democracy anymore, right? The point is that this is exaggerated. There are I guess there are two issues with this graphic. One is this kind of the type of visualization suggests kind of a time series that we're looking at, but if you actually look closely, this is not a time series, this is not an overtime comparison, but we're actually comparing different birth decades. So this is actually a generational shift rather than an overtime shift. So that's one big difference, or kind of slight issue that I have with this. But the other point is the underlying data. And the problem here is that this is based on the World Value Survey, and the World Value Survey actually measures this question of how essential it is to live in a democracy, not as like a percent in a percent scale. Do you agree? Do you disagree? But it's rather a 10-point scale of the average importance or of the importance of living in a democracy, right? So respondents in the World Value Survey actually answer how important is it for you to live in a democracy on a scale from 1 to 10. And what the authors of the study on the left decided to plot was the percentage of people who chose the maximum category on that 10-point scale, right? And that on that, if we kind of use that as a measure, then yes, there is a stark decline in people who say that it is essential to live in a democracy. But if we look at the actual average value on that original scale in the World Value Survey, we can see that, of course, there is a decline as well, and we can talk about how problematic that is, but it is far less dramatic far less accentuated than the original graphic suggests, right? So this is a replication using the same data, but looking at the averages rather than just the percentage of people who chose the highest category. And we see, of course, also a decline, but a much lesser decline, right? Of course, you can make an argument that this is much harder to write a New York Times article about, but essentially this is one example where the way the data was presented and the type of data that was presented ultimately exacerbates an impression that otherwise, if you just show the raw data, you wouldn't necessarily have. Okay. The last category is bad perception, and here again, I want to emphasize again this argument that the key point in all graphics and all visualizations is ultimately comparison, and we have to think about what kind of comparison we want to make and want to allow, right? So one example of kind of bad perception or comparisons that are perceptually difficult to achieve are these stacked bar charts that we see here, or one example that we see here. Stacked bar charts can be useful in certain circumstances, but as soon as we want to allow for comparisons within category over time, for example, if we wanted to evaluate whether the green area B down here is smaller or larger than the green area up here, then we're pretty much left to guess, right? Or other comparisons within category across time, right? So depending on what kind of comparison you want to make, this comparison will be much harder with something like a stacked bar chart, and we wanted to, for example, if the comparisons here are within category over time, we would probably have we would be better served if we kind of looked at the bar chart for each category next to each other, for example, right? So here is a case where, because the baseline changes over time, it makes it really hard to compare category sizes over time as well, right? Because just evaluating the length itself is harder to evaluate than if they all kind of start at the same position, right? That's one example for kind of bad perception. Another example is graphics where we kind of see a trend or see some kind of trend. For example, here we have some exponential growth, and the key point here is that the aspect ratios, the ratio of the x-axis to the y-axis, and the scaling can change your perception of the intensity of that growth, right? So if you change the ratio, here you have a much less of a perception of a strongly increasing exponential growth compared to here, right? So we have to keep in mind that by changing these ratios, we also change perceptions with regard to trends and so on, like how extensive these trends are. Okay. So kind of reflecting on these problems, we kind of want to, what we have to do ultimately is think more broadly about kind of perception and data visualizations, right? So the problems that we described previously are not easily solved by the application of good taste simply, or by just following a general rule to kind of maximize information in a plot. Although there might be good general rules of thumb. But what we need to do is we need to know a little bit more about the role of perception in the interpretation of graphs, right? And so one thing to recognize here is that our visual system is tuned to accomplish some tasks very well, and this comes at a cost in other ways, right? So the perceptual system is attracted to, for example, edges, and we can assess contrast and brightness in terms of relative rather than absolute values, right? So for example, when choosing color schemes, we want mappings from data to color that are not just numerically but also perceptually uniform, right? So if we map, just in the example that I showed in one of the previous videos where we looked at the Human Development Index, right? We had this example of Mississippi, which was kind of in this graphic, in the original graphic that is in the chapter, it looked almost like an outlier because it was the only kind of completely white state with the lowest Human Development Index. But of course, that kind of it looking like an outlier was a function of the underlying color scheme that was used, where Mississippi was just below the threshold for a slighter gray hue. Okay, so we have to keep these kind of perceptual. We have to kind of think about how numeric information that is. That suggests like uniform changes, for each unit increase in the measure, also has to translate in perceptual increase. Okay, and there are a couple of examples. Check out the data visualization book for more details. But there are a couple of different palettes and color scales that help create color schemes that are perceptually uniform for different types of comparisons, right? So from the top to the bottom, the sequential grayscale palette, for example, just varies by luminance or brightness. The sequential blue palette varies both in luminance and intensity, or brightness and intensity. That's here. Then we have the third one, which varies in brightness, intensity, and hue. And then we have diverging color schemes with two different endpoints and so on. Right. The fifth, unordered hues, has just different types of colors, basically to distinguish unordered categories. Okay, so depending on what type of comparisons and what kind of structure you have between objects, you also want to use different type of color schemes, right? So this kind of color scheme is suitable for categories that don't have an inherent order to them. As soon as we use a color scheme like a sequential blue to gray or something like that, we implicitly invoke a certain order between those groupings, right? And so that should only be used if the underlying data and the underlying information actually also conveys that type of, we want to convey that type of comparison. Okay. When thinking about colors to group, for example, data points and scatter plots, we also have to keep in mind that there's a relationship between the underlying data structure and the suitability of certain visualizations, right? And here are two different scatter plots with different groupings according to color and shape. Okay, and the key point here is that a color grouping, for example, to distinguish different observations, doesn't always work depending on the underlying data structure, right? So as long as you have kind of as long as you have a sufficient amount of structure in the data, as we have here on the right, then the color scheme can actually be quite helpful to distinguish specific observations, right? But as soon as this structure is lost, as soon as there's not a lot of differentiation between these individual groups, the color scheme becomes essentially unreadable, right? And pretty useless, right? So it's not only about choosing the right color scheme, but it's also thinking about the right color scheme given the underlying structure of the data. Okay. In addition to kind of color schemes, ultimately what we're trying to do with these types of groupings and with these types of graphical tools is to communicate inferences about relationships, right? And the key thing here is that that we can use different kind of elements to communicate relationships between observations, right? So, for example, proximity, things that are spatially near to one another seem to be related. You know, element or you know objects, points in a scatter plot that are close to each other perceptually appear to be related. We have similarity, the shape, things that look alike seem to be related. We have connections. If we make connections between objects, then they tend to be perceived as having a relationship. Continuity, closure, and so on. Those are all kind of aspects of a visualization that suggest relationships and that kind of make people perceive relationships between specific objects, right? And this can be it is important to keep in mind that one, we can use these tools to create certain inferences and create certain perceived connections between observations, obviously not in a deceptive way, but in order to communicate certain results. We can use these as tools, but we also have to keep in mind that there is a certain hierarchy between those different elements, okay? And what I mean by this hierarchy, we can kind of illustrate using this example or the set of examples that is also in the data visualization book. So, for example, here in the top panel, kind of if you look at just quickly at these sets of circles, of course, you're from a perception for your visual perception suggests that of course there are three different groups that are kind of distinct from each other, right? So that's kind of what jumps out to you in terms of your own perception, right? There are three different groups, right? But as soon as we use an additional visual cue, in this case color, we can kind of break that relationship based on proximity by looking at the relationship based on, in this case, similarity due to color, right? So as soon as we have an additional color scheme for certain points in each of these groups, perceptively, what you're focused on more is the belonging to the color group rather than to the belonging of the group due to proximity, right? There are other examples here in the first kind of set. We're kind of focused on the different shape, right? We have circles and squares. But as soon as we involve an additional visualization feature like the size, at least in terms of our perception, what jumps out more is the differentiation between large circles and squares and smaller circles and squares. And again, as soon as we add color into the mix, that kind of in the hierarchy of the relationships that you infer based on that visualization is the most kind of the most obvious relationship between between these objects, right? Similarly here, we have again circles and squares. As soon as we make kind of connections between them, those seem to be related to each other. But again, there's a hierarchy. We can add additional kind of layers to kind of make additional connections. And here, common. This is kind of an illustration of common fate, where we have two different shapes of data points, and connecting them makes it much easier to kind of communicate or perceive the underlying, potentially trends over time and so on, right? So these are all kind of, and there's more. This is a very brief, very quick overview. Definitely check out the book, and there are more readings on these things if you're interested. But the key point is that I want to make you aware of these different kind of perceived relationships and visual cues that we can use in our graphics to communicate effectively the results that we want to communicate, and to make it as easy as possible to convey the comparison that we want to convey, because ultimately our visualizations are about communicating comparisons, right? And there are a couple of interesting studies on kind of the effectiveness of how easily people can actually decode graphics and kind of make these comparisons based on certain graphical representations. And this is one example of one of these studies where people were asked to kind of evaluate which value, either the blue or yellow value graphical representation represents a larger value, and so there are different types of comparisons that can be made. On the one hand, based on kind of position, where we have the same baseline of comparison within, for example, a bar chart. Then we have length. So here we don't have the same baseline anymore, but we're just looking at the length of these bars, which is kind of the example of the stacked bar chart that we talked about. We can look at angles, for example, in a pie chart, or circular sizes of circular areas or sizes of rectangular areas. And it turns out, obviously, also as you look at these different kind of examples, there are better and worse ways of visually representing data when the task the user must perform involves estimating or comparing values within the graph. And in most of our graphs, that's ultimately what we want the reader to do, to make some comparison, to estimate some number, okay? And just in general, as a rule of thumb, we do best judging the relative position of elements aligned on a common scale, right? So that's kind of on the left, the kind of position visualization. As for example, when we compare the heights of bars on a bar chart, okay? Once outside of position and length encodings, things become generally harder, and the decoding process is more error prone, especially when we talk about angles or areas or changes in slope, right? So in general, another good rule of thumb is never use a pie chart, because these angle comparisons are extremely error prone and very difficult to actually, or it's very difficult to actually accurately or effectively communicate these comparisons, okay? So this is all for now. We will kind of talk a lot more about kind of principles of data visualizations throughout the course, but I wanted to provide you kind of a quick intro at the beginning so you're kind of aware, and I want you to really think, like, reflect on visualizations both as you read papers going forward and as you go continue to write papers and create graphics. Kind of try to not just automatically, I'm just gonna do a scatter plot or a bar chart or whatever, but think more, like reflect and think more explicitly about what is the comparison that you want to make, what is the most effective way to communicate the comparison, and then go from there and then build your graphics based on that. So I hope this was helpful in that regard, and I'm looking forward to continuing that conversation as we proceed throughout the semester. But for this week, I think this is all.